Section 2.2, location of center. In this section, we're going to calculate the mean, median, and mode, and then we're going to understand which measures are more sensitive to outliers. So overall in this section, we're going to be looking at different ways to find the typical value of a data set. Why is this useful? Well, together with measures of spread that we'll see later, you can get a good idea of what the whole data set is doing without having to look at all of it at once. So all of these measures, mean, median, mode, are going to give you some idea of what's maybe in the middle of the data set or what you see the most often. And then we can put some things like range or standard deviation with that, or quartiles as we'll see, and we'll be able to get a really good idea of what all the numbers in the data set are doing and what sort of numbers to expect overall. So the first way to find the typical value is the mean, average, or just the mean. And if you've done this before, you've added together all the numbers and divided by how many there were. Well, nothing's new here except for maybe the notation. Maybe you haven't seen this before. So a population mean has a very specific notation. It uses the Greek letter mu, and that mu stands for population mean. So anytime you see mu followed by a number, you know in statistics that's a population mean. And that's why they use that symbol. It tells a lot. It tells that it's a mean, and it tells that it's coming from the whole population, all the values, like they did a census. And you can see here, x1 plus x2 plus all the way out to xn, they're adding data values together. Why the subscripts? It's just a way for them to notate, like data value 1 would be x sub 1, data value 2 would be x sub 2, x sub n is going to be the last data value in this population. So if it was like 1 million people, it'd be x sub 1 million. If it was 10 million people, x sub 10 million. Be a lot of things up there in that numerator being added together, but that's what that subscript n means. It's just going out to the last individual in the population, however many there are. Once you add all those up, you divide by n. And the shorthand notation for this, they use this symbol here. This is a capital Greek sigma, and it just means sum. So you're adding together all the x's, just like you're doing over here, and then you're dividing by however many there are. So that's all that means. The sample mean uses different notation. It uses this x with a line over it. Kind of looks like a bar. They put a bar over it. So, this means x bar. That's how you read that symbol, x bar. They weren't too creative. But you can look at the notation, and this should be a lowercase n here. It's a little typo. But it's basically the same formula. You add up all the values that you saw in your sample and divide it by the number of items in your sample. And that sigma notation, again, is used to shorthand it. The only difference between population mean and sample mean is the fact that population uses sigma, the mu, and sample mean uses x bar. Population uses capital N for the population size, sample uses little n. But overall, you're adding everything together, dividing by how many there are. Okay, so another way to get the typical value is the median. And the median is the value that's found in the middle of the ordered data set. This is huge. Ordered is most important because if you have a data set that's out of order, maybe the lowest value is in the middle. And you're like, oh, well, that's the typical value. But in fact, it's not typical at all. It's the smallest thing that you're going to see. It has nothing to do with like the center of the data set near where, most of the stuff is really happening. So, you always want to make sure it's in order. And if there are two numbers in the middle, you just find the mean, the average of them, to get the median. So for example, if you have a data set like this, 2, 4, 7, and 10, and the median would then be equal to, if we look at this data set, you go to the middle, there's these two numbers, the 4 and the 7. So you're going to have 4 plus 7 over 2, or 11 over 2, and then that becomes 5.5. So that would be the median for this data set. If you're ever wondering, like, median, how do I remember it's in the middle? Well, the median of a highway is in the middle. It's a common term for the middle of something. Now, note there's no consistently used symbol for the median, though this class's book uses capital M. I have seen that in other texts as well, but it's not necessarily the set in stone symbol for this. It's just something that tends to be used more than other symbols. So the last way to find the typical value that we'll see is useful when you have qualitative data, but it can be used with quantitative too. So the mode, this is the data value that occurs most often. So there can be ties. For example, if you've got a data set and there's 3 values that show up 7 times each, and everything else doesn't show up, maybe a couple of times, all 3 of those values that showed up 7 times each would all be the mode. All 3 of them. You'd say, oh, there's 3 modes here, and then you move on. However, if no data value repeats itself, then there is no mode. No mode at all. You just say no mode, move on. So if every data value is there just one time, like up here in this data set in the example, 2, 4, 7, and 10, there's no mode in that data set. All right, so in this example, I want you to pause this and try working through try working through all of them. See if you can think about in order to have an average value of 18, what score must she get? So go ahead and think about that and come back after you have paused this. Okay, so in the first 3, let's go through these. So since it was her whole population of quiz scores, I'm using the mu symbol for that. And you just add up all of them up top, divide it by 8. The sum up top is 141. You divide that by 8, you get 17.625. And actually for this one, if we're rounding here, back that up, we would actually just round that 2 decimal places to 17.63. So that would be the answer they'd be looking for in the homework set. The next one, median, you want to order them first. If they're out of order, you'll get the wrong median if you don't order them like 99 times out of 100. So here, it was an even number of items in the data set. So we have to take the 17 and 18, add them together, divide by 2, and you get 17.5 as the median. And then the mode, well, there's a tie here because there were 2 16s, 2 20s, so the mode is 16 and 20. Now, one thing to keep in mind with the mean, I want to go back here real quick. If you're adding these up in your calculator and just typing all the numbers in and then you put divided by 8, what it's going to do is it's going to add up 15, 19, 16, all the way up to 20, and then it would just add 17 over 8. And you're going to get some crazy, wacky number that's not the right mean. You got to make sure if you're doing this all in one thing in your calculator to put the numerator in parentheses so it knows to add those together first, get that 141 in its little brain, and then divide by 8 after that. So it's really important to put those parentheses on if you're typing that all in the calculator at once. All right, so this last one here, in order to have an average of 18, what score must she get on her next quiz? And we're going to round this to 2 decimal places if need be. Well, what I'm going to do is kind of fall back to the idea, all right, I want to know what the score is going to be. I want the average to be 18. So I'm going to go ahead and just set up this little formula where it's like the sum of all the test scores over the n needs to equal the mu. And start plugging things in I know. So here the mu that we're going for is 18. The sum of all the x's, well, I know that 8 of them added up to be 141, just her original scores. I don't know what the score of the next quiz or, her 9th quiz will be. So I'm going to add x. And then in the denominator, she already took 8. She's taken 1 more. So the n is now going to be 9. So this is, again, here from, 8 plus 1 there. And then from here, you can just solve for the x. And I'm going to multiply both sides by 9 to get it out from underneath that denominator. You can kind of think cross multiplying too if you want to. So 18 times 9 is 162. And then you subtract 141 from both sides to get the x alone. And the score she would need would be a 21. Now, unfortunately, if this quiz is out of 20 points, she's not going to be able to reach that average. But, at least she knows that now going in. All right, so outlier sensitivity, the last little bit here that we're going to look at in this section. The mean and median, they both return numbers that represent a typical value, but one of them is preferred if there are outliers present. So to illustrate this and which one would probably be best in the outlier situation, let's look at this next data set and compute the mean and the median. You can pause and do that. And what you should have gotten here, I'm going to use mu again because it doesn't tell me that it's a sample. So the mu would have been 26.6. The median would have been 14. So which of the measures seems to do a better job of representing the typical values with the outlier in play? And then which measure is less sensitive to outliers and should be used if outliers are present? What you answer for one is going to be the answer for the next. It generalizes. Let's go ahead and try that. Pause. Okay, so the measure that seems to do the best job here, if you look at the mean, 26.6 isn't close to any of these values. It's not close to the 81. It's, this 81 just really blew up that mean and doesn't really represent anything. So the median, however, is pretty close to these down here. Nothing's going to really get close to 81. It's an outlier. But the 14 is pretty close to everything else. So the one that seems to do the best job of representing the typical in this case would be the median. And in general, if there are outliers present, the data set is skewed. You got something like this or something like this, where you got a tail on one side, you're going to want to use the median. It's why they use median for home prices. When you look it up on a Chamber of Commerce, you're going to see the median as the home price. Median salaries. The reason for that, you got a lot of crazy homes out there that are really expensive. If they put that in the average, it's going to make the homes everywhere else in the city seem more expensive on average than they really are. So they'll use the median to report that to not maybe scare people away from their town. So that's just one example of why they would use the median. But in general, if it's skewed, use the median. So what about the mode? You think outliers will affect it? Well, let me fill you in on this. All right. Outliers aren't typical, so probably won't be a candidate for the mode. The mode is the least sensitive measure, always going to be the least sensitive one. And if you look at the rankings, mean, super sensitive. You add an outlier in there and the mean just is like, oh, I'm going to go over there near that thing. I'm going to get pulled towards it. Super sensitive to change whenever an outlier is put in there. The median can shift a little bit maybe, but not a whole lot. When you start adding new data values in there, outliers, the middle might shift a little, but it's not going to move too much. But the mode, probably not going to move at all. Okay, so let's take a look at a visual of this, the relationship between the three and some different distributions. Okay, so visually, when you start looking at the different skewed shapes and the symmetric shape, overall, the mean, it's the most sensitive to outliers. And remember that outliers are way out in the tails. Outliers are over here and here. So your outliers are going to pull the mean, let's see if I can spell, going to pull the mean towards it very heavily. So the mean always gets pulled towards the tail. It's mean to pull a tail of an animal. So think about that. Then the mode doesn't move hardly from the peak, or doesn't move at all from the peak. The median is right in between the two, just as it always is. And then in the symmetric one, mean, median, mode, all in the center every single time. So these visuals, are good to know, and I'll see you, quote unquote,